simplex method and graphic method. By step, I will explain you how this problem will solve up, and after getting the steps, then we go for the numerical part. Okay, so first we have to learn out what will be the basic first step of the graphic method. If you are able to understand why we are using this graphic method, what is the most important thing in the graphic method is, remember, owing to the importance of the linear programming model in the various industries, many types of algorithm has been developed over the years, and some famous mentions that included the simplex method, Hungarian approaches, and others. Here we are doing the best important with the help of the graphic method, that is the most important and the easy method in the linear programming method, right? In this principle and in this method, what they've almost worked for the different types of problems, but gets more and more difficult to be solved up when there is a number of decisions variables and the constraints increases. Therefore, we have to use this concept with the help of a proper step by step, and let's try to understand how these problems will be worked out. So when we're going with the graphic method, the first step is always to remember the problem, what is exactly the problem is. So you have to understand the problem, as we already decided that the problem is divided into two parts. How many parts we have divided the problem into? Two parts. The first part of the problem is always that is maximization or minimizing a certain topic. That can be a two-part: maximization of your profit or a minimization of your losses. So you have to understand the problem. The problem is again divided into two parts: maximization of your profit or minimization of your losses. The most important point again in this is this: you can maximize your profit or minimize your losses, but you have to maintain some constraints as the resources are always scarce. In the step number 2, once we are identifying the problem, in the next step we have to identify your decision variables. What are the decision variables which you have to take into consideration? As we all know, there are number of variables. Like for example, if I'm talking about the production of a product A and B, the product A will be done with the help of labor and machine. So labor and machine will be called as a decision variable. So you have to think properly when you are going to maximizing your profit or minimizing of your loss. You have to make a business context so that your number of products to be produced and what are the number of machine hours required for producing that product, you have to make a proper decision variable. Now, after considering these 2 points on your foremost important, then you have to formulate your objective function. That means you have to use the math, and with the help of mathematical, you formulate your equations, right? You have to formulate with the help of equation. In the math you have to use it, and your equation, we indicate our objective function with the help of z, right? And we write it in the form of, like, constraints are there, put it that constraints in the objective function, and then you finally get your profit. Like example over here, it is given 5x plus 3, but there is a constraint of the total capacity of the labor, say example the 10 hours, and there can be a capacity of machine, that is also a limitation, say example of 20 hours. So when you are producing a product A and B, considering that constraints, that labor is 20 hours and the machine hour is a 10 hours, so you have to find that the resources are very much limited. It can be a labor, it can be a machine, it can be a time, it can be a material, or it can be some, say example, your money. So you have to express all these constraints in a mathematical formula, right? So after coming with the step number 4, then we proceed further with the step number 5. Now you have to plot all these constraints, like in the program of the graph, considering x and y axis. For example, on x axis we consider it as an equation 1, and for the y axis we go for the equation number 2. When we plot all these constraints on the graph paper, now the most important point is to find out your feasible region, right? You have to find your feasible region. Say example, I'm just showing over you, like this is my graph paper, here is my equation x and y, and we plotted some line like this point over here. This is the equation 1 point considering this point and this point, and one more equation is there considering, say example, like this. Like this is my equation number 2. Then you please find out that these are cutting from this 4 points. I just check it, this point, right? we are having a point number this, then we have the point number this, and we have the point number this. Right, now we have point this. Now you have to find out what is the feasible region. Then you have to make sure if the question is given of the maximization, that you have to maximize your profit or you have to minimize your profit. You have two situations. Either you take the feasible region on the lower part or either you have to take a minimum solution of your upper part. This will help you in explaining the constraints. Feasible regions you have to find out. Then plotting that value also, the objective function also, yes, we have to plot your objective function on the same graph, and that will always be a straight line. That dealing with the linear programming, because the objective function always indicate 3x plus 2y is equals to z, right? So this will be a straight line, it is a part of a straight line. Then after finding all the optimum situation points over here, like for example in this case, if I'm taking about the lesser feasible solution, we find it A, B, C, D. So we find that the optimum solution at point number A, point number B, point number C, and point number 3. On all these points, we calculate the Z, right? And all these points have my optimum solution. Like this point will be 0, comma 0, so we write it 0, comma 0. This point will definitely something, say example 3, comma 0. So put it over as 3, comma 0. This point definitely it is in between the two equations we have to solve up, and this point you can take it like 4, comma 0. So write it over as 4, comma 0. This the way 0, comma 4 rather than 4, comma 0. This shows the axis will be 0 and y will be 4. So how we find this optimum solution? Hope you getting it. Right, now after getting with the step number 8, that finding the optimum solution, my next point is to interpret the solution. How the interpretation will be done up, and when we are doing the interpretation, that means we have to find the optimum solution of our problem. What is the optimum solution of the problem? That means you have to find, is this the optimum solution, or you have to set another alternative options, and you can find out the feasible solution for that area also. There can be a multiple point, so at every point you have to find it. Right, now coming with the next step, what you evaluate your selection, and after the evaluation finally you get your answer, that is the one who is Z. For example, if you're considering about the maximum profit, so select the value, you have to select the value of Z having maximum value, as it is a part of a maximization problem. But if Z is equals to minimum, so what we do, we will select the value of Z, putting in all the points by using graph paper, and then find the minimum value of Z from all. Right, so this is the way we use our linear programming method of graphical system. The step-by-step guide I just explained you of. Now with the help of this step-by-step guide, you can solve the practical numerical question. If I'm asking about the next method, that is the most important method again, that is a simplex method. How we solve our problem with the help of a simplex method. Again, the first point is the most point, that in the first point you have to make a tabular. You have to make a tabular of your problem. Then again, your constraints, that should be a constraint, should be a standard form, and remember a non-negative variable and the non-negative constraints are always on the right hand side, because in the table you have to write all your constraints, whatever the constraints are here there. For example, we have given two equations, right, and they have make a product is made up of two constraints are there, labor and machine. So for the labor, for example, for the labor we have given the variable as x1, and for the machine we have used the word as x2. Two constraints now for the product A and for the product B. Now you have to make clear that which variable you are having and which you are not having. So you have to put all the variables, and the variables should always be on the right side. Now further, sometimes we have to introduce the slack value as well as the surplus variable in the simplex method. What is exactly this slack value is? See, whenever we put the equation in this form, say example z, I must say not this way, or I can say we given a constraint, right? And the constraint is example 2x plus 1y is less than equals to 10. And if I say 5x plus 7y is less than equals to 20, that means in the first equation, if I am checking up 2x plus 1y, something is there in between. That definitely, that is the reason it is less than 10. But if something is always there, then it will be equals to 10. So we convert this less than value, right, into an equal value by introducing a slack variable or surplus variable. And how we introduce this? Like the example I am telling you, 2x plus 1y plus contain one constant variable over here, but the value of that will be, say example z. We don't know about how much quantity will be of z. Now I put it as equals to 10. Right? Coming up with the second equation, if I am talking about the second equation, then you have to write it 5x plus 7y. Now I can't use the word z. If I am using z, so you have to make it like 0z, because the variable z has already been taken by the equation number 1. And if nothing is written, that is a 1. Plus now I am making a next variable for second equation, and we take it a variable in the form of a, say, a, like 1a. And what about the a over here will be 0a, right, is equals to 20. So this way we convert our less than variable into, by introducing a slack or surplus and making the equation equal. So this is an example of slack variable. This is an example of introducing a slack variable. What about, ma'am, if I wanted to introduce the surplus value when the equation is given you more than 10, right? After creating the step number 2, that is a slack or a surplus value, our third point is to create that initial tabular. Yes, you have to set up the initial tabular, that is the rows and the columns should be there, and in all the rows and columns you have to define your objective function, your slack and the surplus value, that is all on the right side. What will be the left side over there? Will telling you some constraints, but that constraint is a variable constraint and that is on the column side. Now in this point we have to consider some more important steps, like we have to introduce the most negative coefficient in our objective function, that is a row wise. Indicate which variable is more beneficial to you and you want to improve that point. And in this scenario, like if I'm talking about this example, we have introduced two things, that is z and a. Now I have to find out whether z and a will be in which point, right? So you have to find out, what you have to find out, the variable which is more beneficial and you want to increase for improving your objective function. So you have to select the existing variable to whom you want to replace the existing one with the new variable that increases your objective. So for that, what we have to do, we have to calculate the ratios, and that ratio for each row has to be calculated on the right side, and that right side constant by corresponding coefficient. What are the key elements you have to find out? After getting the key elements from the coefficient, you find it, right? Then you have to find the smallest positive ratio, that is the variable which leaves the basis. Like that is the smallest one, you replace it, and the best one you put it over there. Now you use the pivot operation, like after using that one, which one with a more updated one, which one give you a more optimal solution. Then again you have to update your tabular by using the adjustment, recalculate your tabular with this process once again, and finally now you check out your optimality test. If all the evaluation function which you have done up reaches all the positive value, that means there is no negative value is there, then finally your optimum solution has been achieved. So if no negative value, then again you have to use a pivot, again you have to calculate your value once again, entering the new variable with the existing variable, and then again you have to interpret your solutions and you have to work up again and again and again till you find your feasible or optimum solution. This is the way how the simplex method goes on. But now point arises, ma'am, sometimes the students always in a dilemma, ma'am, which method is more easy and which one gives you a best and optimum solution? My answer for this question is like all two methods, either as a graphic method or a simplex method, both has their own constraints, both has their own merits and demerits, but you should know where we should use these methods and that method will give you a best result. So you should have a command in both the result, and both is very much helpful for the real life problems also. Now coming up to the next point, if I'm talking about the more difference between the graphic and the simplex method, the first method, that's a graphic method, it always been suitable when we have two variables. If more than two variables, then the graphic method will create a little bit problem. Rather, we can use the simplex method in that case. Right. So we can say, ma'am, for the complex information, we can use the simplex method. Yes, for the complex problem, but for the very small problems, you can definitely solve the graphic method. If I'm talking about the objective, yes, the objective can be both in case of a maximization and minimization, both can the objective as a same function. Now talking about the next point, feasible region. Yes, there is no concept of feasible region in the simplex method. It does not provide any visual approach, but the graphic method shows with the help of a diagram, with the help of the graph, you are able to find out which is your feasible region area. So this is a difference you can say. Like efficiency, if I'm talking about this, simplex method is more efficient when we are talking about a large scale problem. But once there is a large scale problem, this graphic method is not so much efficient. So you can use the graphical method, but in the case of only small problems, like for the two variables, you can say, right? The next step is the sensitivity analysis. Very important point over here is the sensitivity. If I'm talking about sensitivity, how much sensitive the data is, when your data is very much sensitive, you should use the simplex method as it will gives you a billion answer and it is very effective even. But if I'm talking about the graphic method, yes, the graphic method sometimes help you in getting the visualization properly, but it is not so much useful when your data is very sensitive. If I'm talking about the initial feasible solution, yes, it gives you a very feasible solution. But when I require my solution to be very optimum level, then I use this simplex method, and we are using the techniques like big M method, right? Interactions that it does not involve the expected integrations that will be our optimum answer. It will help in getting the simplex method will help you in getting to reach till the optimum level. Coverage, if you are talking about the coverage, yes, it gives you a guarantee to find out the optimum solution, but condition is you have only basically two variables. Then if I'm talking about the guarantee to find the optimum solution for all problems, all type of a problem, but basically solution for two variable problem, it can be helpful. Algorithm, normally it uses a geographical algorithm and it is used in alphabetical, that is a mathematical, I must say. Right? In the math we use that's an algebraic method. It always create the equations like in the form of z is equals to like maximization of 5x plus 3y, right? And the constraint 2x plus 1y is less than equals to 15, or 7x plus 2y is less than equals to 20. So we use the algebraic method, right? If I'm talking about the software, yes, can be done manually as well as with the simple software. You can use the graphic method. Simplex method basically used when you have a very good or specialized software, then this method is very easy and can be applied effectively, and your answer will be done in a numerical in a very easy way. Right, you can use your Excel also in the next session or in my sessions, upgraded session, you will get it. This simplex method can be solved with the help of a solver, as well as we can use the data solver and find your solutions in a very simple way. Simplex itself says simple way. Degeneracy handling, no, graphic method will not handle your degeneracy, but once your answer is again requires to be readjustment, that simplex method will help you in getting a degenerated effectively. If I'm talking about the next point, that's a bounded solutions. It may not always find the bounded solution. No, you are not able to find out exact solution in the graphic, but it always help in finding out your bounded solution. Non-integral solutions, it is not at all solving for the LPs with no integral solutions. Whenever there is a non-integral values, you can't use the graphic method. But if you are using the integral programming, that requires some modifications again and again, then in that case, simplex method will help you. You're getting your answer even when your data is having a non-integral solution. So these are the different ways in which we find out how the simplex method and the graphical method can be used on the condition, on topmost conditions where you feel it more effectively. But nowadays that we are getting more effectively and sensitive analysis, then we're going to the simplex method. But yes, it is limited to its applicability and especially for the larger problems. If I'm talking about, ma'am, we can use the graphic method everywhere, the answer is no. We can't use the graphic method in every situation. We have got some limitations in the graphic math method, but if I'm talking about the simplex method, yes, you can use it everywhere. And it can help you in getting your answer in an optimum solution, right? For upgrading yourself and finding out how we can use this method with the help of an Excel